You understand? Any parameters of science or any object, is being controlled, or let me say, a field is definitely any region or platform, you get, where any physics parameters, you understand, is experiencing, you understand, a field is any platform where physics parameters or physical parameters, let me use that word, physical parameters. When I say physical parameters, now the parameters could be a body, you understand. It could also be an uncountable entity, let's say a charge, you get. Now when this charge is experiencing somewhat application of force or movement of when this charge is actually experiencing change in its direction in this particular platform, we say that this particular object is in its field. Electric field is defined as the electric force per unit charge. Here we are looking at the mathematical formula. You get, the electric field is defined as what? As what? The electric force per unit. Are you saying it? Per unit charge. Now, our charge will be given as Q. You get? Now, this is our electric field. Here is our force. Now, this is the charge. You get? Now, it means that force is being experienced in that field, and at the same time electric charge is being experienced in that field. So if you are to analyze it in a layman word, you can say it is definitely a platform which has in existence, it's a platform or a terrain, you understand, or an open ground which has electric charge in existence. Now this electric charge that is in existence is now under the influence of what? Forces. You understand? So any platform that has electric charges in existence with the effect or the influence of what? External forces, we say that such platform is what? An electric field. It's been stated that the direction of the field is taken to be the direction of the force it will exert on the what? Positive test charge. Now the electric field is radially outward from a positive charge and radially towards a negative charge point. What are we saying? Meaning that an object that is what? Charged could be what? Positive. You understand? An object that is what? Fully charged is what? Positively charged. Now, if it's going to transfer electron, now the body that is actually transferring electron through will be what? Negatively charged. That is, this is negatively charged and this is a positively charged body. Now, there are movement of what? Electric charges from here to here. Now, meaning that these electric electrons or these charges are actually moving from a charged body to what? An uncharged body. So at the end of the day, they are going to have something like this. And at the end of the day, the body that is being charged will become what? Positive. That is if the whole charges in this what? Charged body is being transported into the uncharged body. So that's just the idea as regards what the explanation as regards electric field. Now, the SI unit will also be force, Newton per what? Coulomb. That's the SI unit for what? Your electric field. So from there we can now say our E could be, instead of using E subscript F, E could be F over what? Charge, or F over what? Smaller Q. So this is the formula for what? Your electric field. Now after that we'll proceed to the electric field of point charge. That's what we call electric field of what? Point charge. In terms of electric field of a point charge, we are looking at a specific region. You don't understand. If you have, here's the platform now. What we first derived was what? E equals what? F over what? Your small q. But if we are to be specific, that is, we are looking at this specific period now. Specific point. This is a point. You understand? So if we are going to look at the electric field of this point charge now, you'll be using another different formula which says that your E will equal to what we call your K Q R squared. What do I mean? It means that in this particular region, you'll be borrowing the knowledge of what? Your normal F equals what? Big G B small m over r squared, meaning that there is what? Meaning that you are looking at your charge or charges between two particular bodies. You understand? This big Q is the charge of the environment, the big platform. while your small q is the charge of the particular body or element, the point element where which you are considering. So we are looking at now your k is what we call constant of what? Proportionality. So this your constant of proportionality is now given as what? 1 over 4 pi e naught, which is the same thing as 9 exponential what? 9. You understand? So this particular constant has a value. Hope you are getting it now. So if you are going to calculate your electric field or point charge, you have to use this. But if you are going to calculate your electric field normally without inclusion of your point charge, you use this particular formula. So hope we could get the two different formulas that will actually be used. So let's proceed. That's what we call electric field intensity. So how do you obtain that? Under electric field intensity, we said electric intensity E of an electrostatic field at any point is defined as the force per unit charge which exerts at that point. So there is what we call electric field intensity, and there is what we call electric field. So under our electric field intensity, you get your E, which equals to your force over what? The charge. Now this region, remember we said in this case F is what? K Q1, Q2, or just say KQ, the big Q, the small q, the over. Now it is this force that you're actually going to put into what? The value of force. So if you do that, you get your E to be what? Your Q1 over R squared. Now you now put, this should be divided by Q. So from there you apply your mathematics, then your Q, that is the big Q small q over R squared, will now give you times 1 over Q. So where this Q cancels this Q. So your electric field intensity will give you, let's use that as I. Electric field intensity will now be what? KQ all over R squared. That's the value for your what? Electric field intensity. Now if you are to introduce the value of your what? Q, your K. Remember we said our K is what? 1 over what? 4 pi E naught. Where your E naught is what we call is a constant. It's what we call permittivity, or what we call emissivity. So when we get there, I will explain further how you eventually obtain this your E naught. But it's a constant. But without you looking at that, you can definitely just use the whole of what? Your K, which equals to 1 over 4 pi E naught. So from there, we have actually denoted what your electric field intensity is, which is our I. Now let's go to the next one, which talks about electric field flux. How do you obtain your electric field? If you are to proceed to the next one, we talked about your electric field intensity. So you have to import the value of your F, which is what? K Q1 Q big Q small q over R squared. You import it down here. You understand? So immediately you import it, then you divide it by your what? Your Q. Your F comes in for F here. So you now have something like, so this gives you your what? Electric field intensity, while the other gives you what? Electric field, where you have just force over Q. So from there we've obtained electric field intensity. Now considering the electric field flux, under the electric field flux is just the what? The flux through what? An area perpendicular to the lines of what? Is the product of the E times your what? Your area, that is, use your electric field intensity. We got our electric field intensity, your intensity times cross-sectional area, or you can use D square or R square, all over D square times what? Your area, cross-sectional area. Now, the cross-sectional area we are looking at, not naturally, you are supposed to use 2 pi R squared. But the cross-sectional area in this case is given as what? 4 pi R squared. So it is the 4 pi R squared you input into this thing, then you have 4 pi R squared. So if you are using this as D squared, you must use this as D squared. If you are using this as R squared, you must use this as R squared, so that you'll be able to cancel out. Why are they cancelling out? But if you are to input this value of K, that will be Q. Let's start it again. That is using the actual formula, where we have our I is what? KQ all over what? R squared times 4 pi R squared. Right? Now if K, you now say if your K, if the value of K is 1 over 4 pi E naught, so you input this in here, you have something like this. Q all over 4 pi E naught R squared. Are we getting it? Times 4 pi R squared. So 4 cancels 4, pi cancels pi, your R squared cancels R squared. So therefore, your what? Electric field flux, which is denoted by this sign, will give you what? Q all over E naught. This is the formula for your what? Electric field flux. So if we'll take another example, please, you need to understand it's technical. The example here states that calculate the flux through a sphere produced by a charge of 5 nanocoulomb in a what? In a vacuum. Now, the charge, which is your small q, is given as what? 5 nanocoulomb. Now, in physics, nano here signifies, now you need to know a lot of things. By saying 1 millicoulomb. Millicoulomb is 1 exponential 10 to the power minus 3 coulomb. By saying 1 microcoulomb. 1 microcoulomb means 1 times 10 to the power minus 6 coulomb. By saying 1 nanocoulomb. 1 nanocoulomb means 1 times 10 to the power minus 9 coulomb. If I also say 1 picocoulomb, this is 10 times 10 to the power minus 12 coulomb. So all these signs you must, all these notation you must know, often. So from here our Q is what? 5 times 10 to the power minus 9 coulomb. So we have been given our Q. So for you to obtain your what? Your electric field intensity, electric field flux, which is what? The I times what? Your cross-sectional area. So our I is what? That's your KQ. Now not KQ. Q over 4 pi E naught